All right, seventh graders, let's go ahead and get on this homework. I got all the odd ones tonight. Number one, we see 5 is something that, is it less than, greater than, or equal to absolute value of 7? The absolute value is negative 7, excuse me, is 7. 7 is definitely bigger, so this is less than. Number 3, absolute value of negative 3 over 5 compared to negative absolute value of 5 over 8. This is going to give me a negative value. So this is going to be bigger because it's going to be positive. That's negative. Took the liberty of pasting this in for us because it's asking us for the box and whiskers here. I want to explain the box. This is what you would draw. This is why. First, you've got to put these in order, all right, from least to biggest. So the smallest number would be 24. Next smallest number would be 33. Next smallest number would be 37. Next smallest number would be, oh, I'm sorry, it wouldn't be 37, it would be 35. I missed 35. So let's put this to 35 and then 37. All right. Next one would be 41. Next would be 43. Next would be 45. And they've got that in there twice. Next would be 47. And then 49. And of course, last but not least, 56. Now from here we see our range is from 24 to 56. As everyone see over here where they got 24 and 56. Now, now we're going to have to find the median. The median can be found by crossing out one at a time to get to the middle. So I use a highlighter here. Cross out one side at a time. One, that one, and there, 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 and there. That means the number that is going to be the median will be 43. That's how we got 43 over here as the median. Next, we got to find the middle of the numbers on each side. There's 1, 2, 3, 4, 5 numbers on each side. Again, I would cross off one at a time. Ooh, give that back. There we go. I'm just going to put these in highlighter again, but in blue. Cross off one side. Oops. I'm going to have to make this purple, sorry. Cross off one side, cross off another. Cross off another, cross off another. That quartile is 35, and that's where they got 35 here. On this side, I would do the same. Crossing them out gives me 47. That's where the quartile here. We've divided it into 4, all this information, right? So the first quartile is from 24 to 35. Second one's from 35 to 43. Next one's from 43 to 47. And the last one's from 47 to 56. All right, we're going on to the next one. Find the number of bases, edges, and vertices of the solids. All right. So first, the faces of the first one. Faces are the side, all these faces that you see. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, and then there's a side up on top and on bottom. That means 11 faces. How many edges now? Edges are all of these long sides that make like an edge, right? So we said there was 9 up top, right? 9 faces. So that's 9 there, 9 here, and then there's 9 going around the side. 9 times 3 is 27. So there's 27 edges. Now I have to count up the vertices. The vertices are all these pointy corners, right? So when I count up all the vertices, I'm pretty sure I'm going to come up with 18. And that's because when you count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then there's 9 on the bottom here, that's going to give us 18 vertices. All right, let's look over here. How many faces do I have? Well, I see 1, 2, 3, 4, 5, 6, 7, and then the bottom makes 8. So I would say there's 8 faces. When it comes to edges, we're going to have those 8 edges on top, right? And then we're going to have 8 on the bottom. So I think we're going to have 16 edges. And we're talking vertices. Each of one of these corners here, so that's 8, plus the top one, right? I'm thinking that's going to give us 9 vertices. I'm just going to double check that by counting it here. This would be 1, 2, 3, 4, 5, 6, 7. Ooh, I made a little error there. There's 7 on the bottom, 1 on top. That's going to make this 8, not 9. I thought with 8 faces, it'd be 8 vertices. Turned out there was just 7 of them there. So this is going to be 8 vertices. All right, let's go down to number 10. It says apply the properties of exponents to write the expression as a single power. State the property used. All right, if I do number 10, this is going to be 3.7 to the 8th, right, over 3.7 to the 5th. We're going to use division, right? So this is going to equal 3.7 to the 8 minus 5. Small one gets subtracted from the bigger one. That's going to equal 3.7 to the 3rd power. Okay? So we know this is 3.7 to the 3rd power. Okay? And now we just have to state the property that was used, which we said was division, so it would be property of quotient property. Okay? I'll be happy with this answer right here, but property of quotient property would be the one that we use. Let's go ahead and go to number 12, writing exponents using exponents. Okay, number 12, I got 1, 2, 3, 4. That's 0.2 to the 4th power. Number 13 is yours to do. Number 14, I got negative 1.5 3 times. So this would be negative, in parentheses, 1/2 to the power of 3. Okay? Don't forget to put the parentheses around the negative as well. Now I got 1, 2, 3, 4, 5. So this would be 1.5 to the 5 or to the 5th power, right? And then this is negative 4 over 3, 1, 2, 3, 4 times. So this would be negative 4 over 3 to the 4th power. All right. All right, let's move on. When I go to number 20, I have to work some over here. Evaluate, in other words, solve it. 0.3 to the 3rd power. So if I'm using my calculator, and let's not forget how to write this, it would be 0.3 times 0.3 times 0.3, right? I know 0.3 times 0.3 would be 0.09, right? Times 0.3, that's going to go ahead and be, let's see, it's going to equal 0.20, no, 0.27. Okay, we'll double check it with the calculator. 0.3 times 0.3 times 0.3, 0.027. All right, let's move on. Next would be number 22, 0.5 to the fifth power with a negative in front. Remember, the negative is not affected by the 5. So, I'm sorry, let's first put this as 0.027. Okay, now let's work on number 22. This means our answer definitely will be negative, and we're taking 0.5 times 0.5 times 0.5 times 0.5 times 0.5, right? 0.5 times itself 5 times. So this is going to be 0.5 times 0.5, that's 2, that's 3, that's 4, that's multiplying it to itself 5 times, and that's our answer. 0.03125, 0.03125, 0.03125. Make sure I wrote that right. Yep. All right, let's move on to number 24. 24 is just 1.2 times 1.2. Well, when I do that, 1.2 times 1.2, I'm going to get 1.44. All right, next is number 26. This would be 1 over 12 times itself 2 times. So 1 over 12 times 1 over 12. Remember, that's 1 times 1 is 1, and 12 times 12 is 144. So this gives us 1 over 144. Number 28. This is going to be negative because the negative is not affected. Now we got to take 3 over 2, multiply it to itself 4 times and get a number here. Okay, so we're going to have 3.2, or excuse me, 3 over 2 times 3 over 2 times 3 over 2 times 3 over 2. Many of you have already realized 3 over 2 is 1.5, which means you would multiply 1.5 times itself 3 times. You could also say 3 times 3 is 9, and 9 times 9 is 81. So this would give us an 81. Now we'd have 2 times 2 is 4, and 4 times 4 is 16. Right? And if I was going to evaluate 81 over 16, I realize that's 81 divided by 16. And that would give me 5.0625. 5.0625. All right, off to number 30 now. I'm going to erase all this so nobody gets too confused with the work and the answers. Number 30, I'm starting over here. Simplify the expression, write your answer as a power. Well, I know that I'm allowed to add my power, right? But I also know anything to the power of 0 is 0. I want to make sure that 0, I'm going to click on this and make it a little bigger so I can actually see it better. That's definitely 0. So since anything to the 0 power is itself, this is going to be 0.75 times 1. That's going to equal 0.7 to the 5th power. Number 32, I'm dividing here using my power quotient property. This is going to be equal to 4.5 to the 5 minus 3 power. And that's going to equal 4.5 to the 2nd power. All right, number 34, whatever power to a power, I can multiply. So this is going to be equal to negative 3 over 4. That negative is a part of it. And I'm going to put this all to the 10th power. Let's see, I got to get to number 36 here. It says, which expression is equivalent to 0.47 to the 9th power? Well, I know this one's 3 plus 3, right? Because we're multiplying, we can add it. That's 6. That's not going to work. C is, it looks like 6. No, that's 0. And then 9, that's going to bring, that's going to be 1 over 9, it looks like. That won't work. So let's just write these out so we know what these are. This is going to be equal to 0.47 over 6. That's not going to work. This is going to be equal to 1 over 0.47 to the 9th. That's not this number up here. This one is going to be 0.47 to the 18th. Because 3 times 6 is 18. That's not going to work. I hope there's an answer here. This one is going to be equal to 0.47 to the 12 minus 3. 12 minus 3, finally, that's 9. So this should be 0.47 to the 9th power. That is the right answer. All right, going to number 38. Geometry. The area of the rectangle is 5 over 8 to the 12th square feet. Find the width of the rectangle. We're trying to find the width. Remember, the area is this. So the area is 5 over 8 to the 12th. That's got to be equal to 5 to the 8th to the 3rd times some number, which we'll call W. If that's true, what's the only thing, okay, that I can go ahead and put here? It would have to be, remember, this is like, well, I could go ahead, since I'm multiplying this here, I could divide 5 over 8 to the 3rd power away from it to get W by itself. Whatever I divide from one side, I divide from the other. And now I have a division problem where my base is the same. 12 minus 3, that's going to be 9. So my answer is 5 over 8 to the 9th power. Does everyone see how we got that? So 28 would be 5 over 8 in parentheses to the 9th power. Last one for me is 40. I think that's the last assignment, thank goodness. The appropriate frequency and vibrations per second of a note of a piano is represented by the equation F equals 400 times 1.059 to the n power, where n is the number of notes above a 440. Each black or white key represents one note. All right? Compare the frequency of A to the frequency of A 440. Well, let's look at it. this is the answer to A. Okay. Remember, this is 440 to the 1.49 to the n power, where n is a number of notes above this. Okay. When I go here, each note, it says, represents 1, right? So uh, frequency A, which we said is the approximate frequency of a note on a piano, is represented by this, where n is the number of notes. All right, so the frequency of A by itself is double the frequency of A 440. A is here, right? And it's double it. So to show the work, it would look like this. A is 12 notes above A 440, okay? One, two, three, four, five, six, 7, 8, 9, 10, 11, 12. A, okay, it's 12 notes above. Let's see, alternate frequency, note on piano is represented by F. Okay. All right, so F is equal to 440, right, to the power of n, which is going to equal about 880. We know this because this is a 12 here, right? Remember, A is 12 notes above 8 of 8, right? So we're talking each blank represents a key of one note. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're talking 12. When we do this, we got 12 to power here. We're going to take this to the 12th power, multiply it by this and get this. The frequency of A is about 880 vibrations per minute. Now it's saying that means A to the 440 equals this to the 0 power equals 440. Anything to the 0 power is itself, right? And the frequency of A, the 440, is about 440 vibrations per minute. So the answer is 440. Okay, it's about twice the frequency because 880 is about twice of 440. All right. Next, estimate the frequency of D. Is your answer reasonable? All right. Now we got to estimate the frequency of D. Let me get some room here. I'll put it over here. D is 6 notes above A. All right. Let's see, D. 1, 2, 3, 4, 5, 6. Okay. Or halfway between A and F. Frequency should be about 640 BPMs. So the estimate is reasonable. I don't expect anybody to get number 40 right. I'll let you know in class that no matter what you got, I'm just going to probably just give you an extra point for this or just rule out the question altogether. This was like crazy hard. Hope you were able to do the rest of them though. They seemed good enough. And I will see you in class. Have a great night.